morning, good afternoon, good evening, wherever you are. On behalf of JSCM, welcome to our Spring 2022 webinar series. Climate change is a global challenge. It is a topic that impacts everyone and an important supply chain issue, of course. So while we were organizing that event, we were talking that this is not a typical emergent topic, but it's rather an emergency topic. Therefore, the purpose of this webinar series is to increase scholarly attention to this topic, and we will have 3 such webinars. We start today with why should supply chain scholars engage in climate change scholarship. Next Thursday, we will look at what are some examples of research questions that supply chain scholars could consider investigating on climate change. And on March 3rd, we will ask how can supply chain scholars move from a research methods and data sources perspective. So thank you all for joining, and I'll hand over to Dave Cantor, who is our moderator for today's session. Dave.
Well, thank you, everyone. Thank you to the Journal of Supply Chain Management for providing Lutz, Andreas, and I with an opportunity to organize this climate change webinar series. We appreciate the opportunity to raise attention to this issue, as Lutz had just mentioned. So what I'd like to do is to begin to provide you with an overview of what we are trying to accomplish today. We invited several guest speakers to provide us with more information about why this is an important topic. So what I have here are the names of the guest speakers, including Anders Lieberman, Andreas Whelan, and Michael Gersten Laharash Guntica, who will share their perspective on this important topic, why we should be conducting research on climate change. Each speaker will have approximately 15 minutes to provide you with an overview of what's going on the topic. We encourage you to submit comments via the Zoom chat tool at any point during today's session. And as your moderator, what I'll do is I'll take some of those questions and comments that you submit. And then after each presenter completes their presentation, I'll ask the presenters some of the questions that you submitted via the Zoom chat tool. Towards the end of today's session, we have a survey that we will share with you. And we would like for you to think about submitting comments on these 3 questions. We'd like for you to share with us 3 to 5 climate change research topics or questions that need further attention. We'd also like for you to share with us what you think are some interesting research methods or data sources that should be considered when conducting research on this topic. And then we would also like for your suggestions on how we can move this conversation forward. As you know, there will be 3 sessions on this issue, including today's session. We'll come back together again on March 3rd and March 10th, and we'll share your comments on those survey questions to our presenters before the March 3rd and March 10th session, so that they have a better understanding of what are some of the issues that you would like for them to share with us. So as I had mentioned, we're going to start with Anders, and we're delighted that Anders and the other guest speakers are with us today. So Anders, would you like to go ahead and share with us your thoughts on this particular topic?
Yes, thank you very much for the invitation. I'm the physicist here, so I'm supposed to tell you about climate change and why it and how it might affect value chain management or supply chain management. The temperature of the planet is increasing. It's not increasing every year, but there's obviously natural variability in the system. You can see here the temperature evolution of the last 150 years, actually 170 years now. And the temperature has increased by about 1.2 degrees. That's the global warming everyone talks about. And it's really not about this temperature increase. The temperature increase is just an indicator of the change that is happening on the planet, the climate change that actually starts to impact already a number of systems and will also increasingly impact society. The reason for this temperature increase is very fundamentally understood. I put these three people up here because we really understand the basic physics of this climate, of this global warming. We know the absorption and emission spectra of the molecules that are involved, CO2 and CH4 mainly, both carbon molecules. And you just have to go, even without any climate physics inside, you go to quantum mechanics and black body radiation, and you understand what is done with the sunlight that comes to our Earth, and what's done with the infrared backward radiation that the Earth emits into space by these molecules. And if you do this, then you realize that for every doubling of the CO2 in the atmosphere, you get 1.1 degrees of global warming just from this radiation effect from quantum mechanics. And then the first feedback kicks in, and you know that from thermodynamics, Ludwig Boltzmann is here, you know that a warmer atmosphere can hold more water vapor. And this water vapor, again, you go back to quantum mechanics, and tells you is also a greenhouse gas. And this adds another 1.5 to 2 degrees of global warming to the 1.1 degrees you got earlier for every doubling of the CO2 in the atmosphere. And this gives you the 3 degrees of global warming that you will get for every doubling of this atmospheric CO2 concentration. That's the climate sensitivity that stands already for more than 100 years. And it shows you how fundamentally we understood that the temperature of the planet will increase if we increase the CO2 concentration, if we continue to burn oil, gas, and coal. And this is the emissions that we have been putting out in the past. You can see the black line here is actually the observed the CO2 emissions into the atmosphere. And we follow, and I show you this, basically we followed up to 2014, and a bit further on, we followed this red curve that we call RCP 8.5, which will give you about 5 degrees of global warming. And you can look at the blue curve here as one of the possible Paris Climate Agreement curves. We have already deviated from the red curve a little bit towards the blue curve, but you can see the huge challenge that we have between the red curve and the blue curve. And what's most important to take home is that the CO2 that we put in the atmosphere is similar to microplastic in the rest of the environment. It stays there for practically forever, which means that the temperature of the planet will increase as long as we put CO2 into the atmosphere. So in order to stabilize the temperature of the planet at any level, be it the 1.5 degrees that the Fridays for Futures are demanding, or the 2 degrees that is the upper limit of the Paris Climate Agreement, or the 5 degrees that you get if you don't do anything. If you want to stabilize the temperature of the planet, you have to get to zero emissions eventually, and that is the huge challenge. But it's also good news for businesses in general, even though it doesn't sound like it, because it means we don't have to do less of something. We have to do everything different. We have to do everything fundamentally different, and this is how you can make money with climate protection. This is the two temperature curves that you get from these. It's actually 5 degrees of warming here, even though it looks like 4 degrees. That's because the reference is pre-industrial, and it's this is the IPCC curve here. So this is just for your reference. We have already seen a number of changes in the climate, which I'm not going to talk about. I'm just brushing through them so that you can see that this is actually happening. Coral reefs are dying everywhere. Even if we keep the Paris Climate Agreement this is the death curve of the coral reefs on the planet. Even if we keep the Paris Climate Agreement, we'll practically kill all the coral reefs on the planet, including the Great Barrier Reef in Australia. The Arctic sea ice is melting dramatically. This was 1979, first satellite picture of the region. This is 2020. Even if we keep the Paris Climate Agreement, we'll practically have the North Pole ice-free in 20 years. Ice sheets are destabilizing in the north and in the east. In the south, you see here the Western Arctic ice sheet on the left-hand side, which has probably been destabilized and will lead to a sea level rise of 3 meters over hundreds of years, but unstoppably. The Eastern Arctic ice sheet is not yet destabilized. You can see here on the right-hand side, if it does, then you get another 3 meters of sea level rise. Sea level is actually increasing worldwide, but I also don't want to talk about this because it's slow. It's similarly slow to as permafrost is slow, but the big, which is also thawing and releasing more methane gases, more greenhouse gases into the atmosphere. What I want to talk about are weather extremes, because weather extremes is what's actually going to affect us most as a society, as well as our economies. And weather extremes are intensifying under global warming, and people keep trying to capture this in one statement. Weather extremes are getting stronger and are getting more frequent, and that is generally true, but every weather extreme actually has its own physics. So it's not as simple as that, and it's not as easily understandable as that, but you can understand some of this. Some things you can just understand from pure statistics. What you see here behind me is the temperature in summer in Europe as it was measured over the last decades. And you can see that the most likely temperature is here in the center. It's normalized to be the most likely. And you see the standard deviations from this center. And see what happens by just pushing, the global warming is just pushing this curve to the right. And just look at what the frequency with which, or the speed with which an extremely hot summer is becoming more and more frequent under this global warming. That's simply because of because the bell curve is quadratically exponential. So the number of standard extreme heat hot summers that were outside of the third standard deviation before is simply increasing dramatically under warming. So this, it can be understood by statistics, but generally statistics is not such a good idea. I just want to highlight that obviously the Syrian crisis was not caused by climate change, but we have to keep in mind that the 3 summers, or this 3 years before the outbreak of the Syrian crisis, were drought years in the region, and that hit the region hard. Another set that cannot be understood statistically, but physically, is the absolute opposite, and that's not a drought, but it's the flood risk. A warmer atmosphere can hold more water vapor, and the amount of water, that's the Clausius-Clapeyron equation of 1843. So it's a very, very strong law in physics that holds, way beyond Earth. And this tells you that a warm atmosphere can hold more water vapor, and the amount of water vapor that you can actually put into the atmosphere determines the strength of extreme rainfall events, not the overall drizzling that is good for agriculture, but the flood events. And that's why the number of and intensity of flood events will increase, not everywhere on the planet, but as an average. The tropical storms, typhoons and hurricanes are both, these are tropical storms in general, and they're very difficult to understand. They have very difficult physics, but we know, one thing we know for sure, and that is where they get their energy from. They get the energy from the surface water of the ocean they pass through, and that's why we know that hurricanes are going to become stronger under global warming. And that means that also the number of strong hurricanes and typhoons will increase under global warming. So for every class of weather extremes, we actually have a physical understanding. Sometimes we have statistics, but generally, if you wait for the statistics to kick in, it's too late. You really want to understand this physically. And we understand why they intensify. One set of weather extremes, which is particularly important, is particularly difficult to understand, and we're not fully, we haven't fully settled the science on that. Similarly, to a lot of topics, right? Science is never fully settled, except for on the fact that the temperature of the planet is really increasing if you increase the amount of CO2. But these weather extremes that I want to talk about next and finally are really so important that we have to warn society and the supply chain managers of the world early, because they will, if it turns out to be true that the jet stream is actually becoming more and more unstable under global warming, then this will be highly relevant for your businesses and for our societies. The jet stream is this wind field that you see here, the red wind field that flows around the globe in mid-latitudes. And it's actually separating the cold Arctic temperatures and the cold Arctic air from the warm and moist tropical air in the south. And what you see here is a destabilization. It's because the jet stream becomes in this simulation, which is sorry, in this picture here, starts to meander. And when this happens, then suddenly, and that is in a matter of days, because this is now weather that's influenced by climate, then cold air from the north is suddenly penetrating the south, as you can see here, where there is actually a lot of moisture in the air because the air was warm before. And similarly, if it goes the other way, if one of these meandering bellies is going northward, then you suddenly get a heat wave over Greenland. And I'm just telling you this because this has happened a number of times in the past. Hurricane Sandy was actually caused, not the hurricane itself. The hurricane itself, was a normal hurricane starting here in the subtropical Atlantic and then going towards the north, following the path and getting stronger and stronger. But then it was already on its path towards the North Atlantic in order to die in the cold, when meandering of a jet stream actually turned its path and pushed it into New York, where it destroyed New York in 2012. At the same time, we had a heat wave over Greenland. But this has happened a number of times. And you might remember in the winter 2017, 2018, we had an enormous snow event in the northeast of the United States, where the economic activity actually ceased for 2 weeks from Chicago to New York because of a meandering of the jet stream and the associated snowfall. The same happened again in the next year, and we have this actually quite frequently in the past. I can go through this a number of times. The jet stream related events were the summer in 2019, in the Midwest in 2020. The temperatures actually dropped by 33 degrees or 34 degrees within 24 hours in Denver, Colorado. The huge heat wave in summer 2010 was caused by that. The flood event in Pakistan at the same time, which created the biggest freshwater lake on the planet and led 10,000 people, made 10,000 people flee from their homes, was caused by the jet stream meandering. And we actually have the possibility that this meandering could actually impact all 3 bread baskets on the planet, where currently our wheat is grown at the same time, because there's a synchronization through this wave structure. This actually impacts our supply chains. We have a supply model for that where we actually can track impacts of weather extremes. Here we have floods along the supply chains, and can investigate the economic impacts here. But this is just on the side. This is not physics. This is my economic work. In summary, I want to say that a number of studies have shown in the meantime, in the last years, by from Stanford University to the northeastern Ivory League, and also our work and our institute, have shown that the climate damages that we get if we increase the temperature of the planet by more than 2 degrees far exceed the costs that we have to bring, that we have to pay as in the world economy in order to stabilize the temperature of the planet. These are macroeconomic estimates and calculations. They can be easily understood actually in light of the shapes of the different curves of the climate damages and the mitigation costs. And I don't want to go too deep into this. The fact is there will be winners and losers of climate change. And we have to, and that's just a personal statement now, we have to, as a society, set the rules such that those are winners that actually lead us into a safer future. Thank you very much. And I'm really happy to take any questions. I'm doing this for more than 20 years now, so please don't hesitate also to ask the critical questions.
Thank you, Anders. I appreciate your presentation here. And as a reminder, participants are free to submit questions through the chat tool. And as they come through, I'll filter through some of those and share that with the presenters. One question that came through has to do, are there any particular mechanisms that might work better than others to help change behavior? Anders, I mean, in your 20 years of research, what are your thoughts in terms of how do we incentivize change?
Yeah, well, you see, it's really good if you do something yourself, right? I would not discourage anyone from driving less, flying less, eating less meat, and what have you, right? But it's not the point. We have to get to zero emissions. So going to the street like the Fridays has really pushed society a long way towards a solution. But the solution can only come from the top. So we have to elect the people that do the real change and get structural change so that if you go into a supermarket, you cannot buy anything anymore that was produced with carbon dioxide. That has to be the solution. We have 20 years for that, but it's the whole world economy. So it's a big thing. We have to start now, but it's not going to be solved by individual contributions. I'm sorry to say that. I know people love that, to hear it, but that's not the one. It's the biggest thing you can do as an individual is take this serious, this problem, and don't shy away from the structural change that's necessary, because that's what's coming now. And people, if you don't want to, if you have a crisis with Russia and you don't want to be dependent on natural gas, go renewable, because that's the path you have to go anyway.
Great, thank you. One other question that came in, do you think positioning supply chain sustainability research in the scope of climate change research is an important way to get the message out?
I think climate change, even if you don't recognize it as climate change, will become one of the most important issues of your daily life as a supply chain manager. So research that focuses on this will become very important. It's or actually is already important, and through the side door, if you like, that'll raise awareness, because people will just realize, oops, this is happening over and over again. The problems get stronger and stronger. It costs because we're not prepared, and that'll actually raise awareness, and that actually will also do something politically, because eventually it's the economy that has to do all the heavy lifting, right? It's not going to be, it's the economy. The power in society is the economy.
Great, thank you, Anders. We're now going to go ahead and hear from our next presenter, Andreas Whelan. Can you go ahead, Andreas, and share with us your thoughts on this topic?
Sure. So thanks a lot. Thanks to everyone here. Thanks also to Anders for this great presentation. So we can learn from Anders and his peers, from climate scientists. The physics is clear about climate change. So the question is now, what can we make out of it in our discipline as supply chain researchers? That's a bit what I want to cover a bit. So like trying to bridge a bit between this reality that we are facing and the way we are conducting research. So that's why I framed my presentation also, supply chain management, a discipline in climate crisis. So I try to provoke a bit. Let's see if that works. So first of all, supply chains are responsible for emissions. Some would say for all emissions. If you really think about this supply chain that I have depicted here, is a very simple product, maybe a sport bag. But here you can see during the production and logistics processes, there's emissions throughout this chain. And you could argue that essentially all emissions on our planet that are man-made are somehow related to supply chains. It might not be entirely true. So if you start a wildfire, then maybe that's man-made, but it's not part of a supply chain. So, but essentially, many or most parts of the emissions that we're seeing outside relates to what we are doing, what we are promoting in our research, what we are promoting in our teaching. So that means also the values that we have in mind, the values of growth, the values of consumer satisfaction, the values of profit result in emissions and result in these phenomena that Anders talked about. So if I really want to provoke, I could say our supply chain management textbooks are guidelines for destroying our planet. I put it here as a question. So the picture that you can see here, that's Southeast Asia, obviously. You depicted here is the destruction of the rainforest between 2001, I think it was, and 2015. So within a very tiny period. So because of palm oil plantations, a type of product that makes supply chains efficient, that is easy to process. So we outsourced food production partly to other parts of our globe to make things efficient. So we followed our textbooks, and by doing so, we are destroying our planet in terms of the climate crisis, but also other planetary boundaries like biodiversity, which is obviously also related to climate phenomena. So this is a bit to provoke. I know textbooks now also have sustainability chapters, but the question is, how far does it go? And is it really, if we think about our supply chain management definitions even, where is climate there? Where are planetary boundaries? So we we have norms ingrained in our definitions implicitly, and maybe we need to make more explicitly think about these norms. Yeah, here I really try to provoke now. So an SCM researcher looking for a new research idea. The house is burning, or the wind is blowing, as maybe Anders also described it, or the floods are coming. And at the same time, we still, and when I say we, I of course don't mean every single academic in our discipline. There are people doing really interesting stuff also that is related to this problem. But if we are honest, if we go to conferences, if we read our many of our journals, then it is like this researcher who then says, Eureka, I will take a TCE lens on supply chain integration. So we should keep doing this. These are important research questions. Theories, though, that are, yeah, let's say minimalistic and not covering all these complexities that also Anders described, but also that maybe describe the complexities even just of the supply chain. I think we need alternatives to this. So this is my personal opinion. You could say, I mean, today we heard Anders here. Now you're listening to me as a supply chain researcher. In a way, these are two disciplinary bubbles. We are living in separate worlds, you could say. In SCM, we are looking at the phenomena that we have been researching for decades, and in climate science, the phenomena that are described are covered. But this is maybe how we see the world. The reality might, and by the way, I checked how often are we using terms like climate change or global warming in our journals. Not so often, and if so, then often not really as the key element of that research. So maybe somewhere in the discussion. Of course, there's great papers covering this, but this is a small minority. And of course, supply chains don't play the key role in climate science. although people like Anders are also studying supply chains and the emissions across that. But I'm really not trying to talk about the majority of researchers. But if we now, this is the disciplinary view, if we look at the phenomenal view, so or how the phenomena are related, then we have to say, as I said before, supply chains are responsible for emissions. So in the supply chain, if we see the supply chain as a system, emissions are created and it impacts the climate system and vice versa. So if the climate system leads to droughts, then food supply chains will be affected. So it's a interrelationship between different systems or systems maybe, or levels of our world that operate on different scales. So I found this recent quote here by Kreuzig et al. It's actually a forthcoming paper as a response to a Nature article where technological solutions were discussed for climate change. And Kreuzig responded, or these authors will respond to this. They say, the time has come to take the potential contribution of the social sciences to climate change mitigation seriously. We cannot afford to pursue engineered optimality while ignoring the social systems underpinning the transition. So what I want to highlight here, and what they also want to highlight, is the role of social sciences here. So we very often think about how can we filter CO2 out of the air, and I'm not an expert, maybe Anders knows if that's to what extent that would be possible in the future. But supply chain management has a strong background in engineering, but it also has a strong background in the social sciences. And I think sometimes if we think about the history also of our discipline, the short history, just a few decades, then often this engineering thinking, seeing management almost as engineering, optimizing, so the vocabulary, even designing the supply chain, etc., as if we are trying to talk about a metro system, a subway system, instead of a social system that the supply chain also is. So what could be then paths to go? Social trust, structured decision processes, impartial rules. So this type of thinking to discuss climate sciences, solutions to climate change related to supply chains, bottom up and top down management systems. And what I find very interesting, also social tipping points. There has been some research on this recently, where we can also think about how can we in our supply chain literature discuss this? How can managers create social tipping points or consumers that will lead to the needed transformation of also the climate reality? I have tried this myself in a paper that I published last year, or that JCM published last year, that I wrote, where I used an ecological theory, but that a theory that is also used in social sciences like urban studies, to show the fluidity of systems, that it's not static engineered systems. So also the interrelationship, like the planetary level where climate phenomena take place, and the supply chain level where supply chain phenomena take place. But then we can suddenly see also how all this relates, and we won't overlook the relationships anymore if we kind of try to understand the world like this. Related is also then the question, how can we, if this model that I just presented, or this way of thinking maybe, if that makes sense, how can we use that also to transform our discipline? So traditionally, that's on the left side here, our assumptions are that we are covering, or that we are dealing with static systems. So this supply chain needs to be controlled. Even resilience in the past was about robustness, getting back to normal, trying to keep it in the same state as it always was. and being reductionist, so only looking at the supply chain without the context, without the climate level, for instance. We had a modernist understanding of the world, so trying really to control everything, trying to also believing that technology will solve things, like blockchain creates transparency for social responsibility, etc. And a panarchical view, that's what I proposed, or like a holistic view of supply chain management, is really trying to go beyond that, really trying to see the world as it is, as something that you shouldn't reduce to systems that are not interlinked, but something that where we really have these interrelationships, for instance, between climate and supply chain, as we also will see in the next presentation, actually. So that's a bit what I would like to propose, but also, yeah, I mean, today we're talking about the what. The what is that traditional supply chain management is very much dominating. Although I can see some change also recently. So there are, especially I would say in JSCM, there is some great space also for new ideas and new ways of seeing supply chains. And I very much hope, and I can only yeah, really talk here to the audience, we jointly have to cover this topic. And if we only have very few years left to get to zero emissions, that's what Anders told us, not a bit less, really zero emissions, that would mean that we entirely need to rebuild supply chains and also reinvent supply chain management as it is, or maybe even get rid of supply chains. And then the question is, what comes after? Is circularity enough? It's certainly a path to go, but what could be other ways to go? So this is a bit what I want to propose here. So with these words, I stop, maybe stop sharing, but also stop talking, unless David, you have some questions for me, maybe.
Well, Andreas, thank you very much for sharing your view. I do have a question that came in. Can you provide some examples of how supply chain can have a positive impact on climate?
So supply chains or supply chain management. So if I think about supply chains, we need to build them in a way that they are at least climate neutral. And I've seen very interesting initiatives recently coming actually also from companies. For instance, Microsoft is now, they have the goal. I mean, the action will be important, but they have the goal to get to zero emissions, but not just for the future or for now, but even historically. So they want to neutralize all past emissions. So I think that's quite ambitious as a goal. So you can, of course, also Porsche is doing this. They have recently announced that all suppliers have to use renewable energy, and those who won't comply, they will be kicked out as suppliers. So strong companies, like big companies, they certainly have the power to do things like that, but it's still material supply chains. That will still mean you build a new car, 1.5 tons for each person that buys the car. So we also need to rethink the way of, then in that example, of transportation, service models instead of ownership models, for instance. So I think there's a lot to do on this path. Now, I'm not sure.
Another question that I see here is, can Anders address how carbon sequestration may be part of the equation?
Yes, I can. We have some techniques to do that. It doesn't even remotely scale to anything that would bring us from the red curve to the blue curve, not even remotely. You know, if you look at the blue curve again, and you can't because I'm not sharing at the moment, but you can see that at 2070, it becomes negative. There's actually negative emissions there. And that's exactly taking CO2 back out of the atmosphere. And people have this dream of building trees and solving the problem by that. That's just a tiny little bit on the planet. You would have to green the entire planet and then still stop emitting CO2, because only as long as the trees grow, you actually take CO2 out of the atmosphere. And a technical solution you have, people have thought about putting iron into the Southern Ocean to increase the blooming of algae and so on and so forth. This is all far from being industrial level and being at a scale that's really helpful in this process. Eventually, we'll have some negative emissions, but basically all sectors have to get to zero, and that's a huge challenge, obviously.
Great, thank you, Anders. I have two other questions here. One question is about kicking out suppliers. Will that hurt SMEs, DEI suppliers? Is this also a consideration? Andreas, do you want to address?
Yeah, I'm just thinking, so kicking out suppliers, again, the problem is we really need to go to zero emissions. So in that sense, we can't afford having in the future, having suppliers who emit anything. So that's kind of the message from that or the homework that we can get from climate science. Will it hurt companies? If I get the question correctly, of course, but that means companies need to transform towards zero emission. I think Anders also has the hand in the air.
Yeah, I just wanted to add that climate change is actually relevant from two sides for supply chains, right? Andreas has just highlighted the one where it's about mitigation, reducing carbon emissions. And this can only, and I want to emphasize this really a lot, because there's a lot of negative energy around, and that's understandable because it's frustrating. I'm doing this for 20 years. When I was starting this, we had 0.6 degrees of global warming. Now we have 1.2, right? Almost doubled in this period. And so it's frustrating, but we have to do this as a society. So it's really, it's not just the supply chains that have to go to zero emissions, but all transportation has to slowly evolve, and we have to make this possible, right? You have to, and it's not easy. It's really, I mean, transportation is the most difficult of all the tasks. You have to, the power supply has to be carbon neutral. That's the big chunk. That's the most important one. And then you have to provide so much energy by renewables that you can actually also get the transportation sector to zero emissions. It's a huge task, but we have to do it together. And yeah.
Great. Well, thank you both for answering these questions. We did have a couple more questions that came in through the chat. We'll try to get to them at the end of the presentation. But what I'd like to do now is ask Michael and Laharesh to share their perspective on this topic as well. So I'll turn it over to Michael, I guess, to lead us off.
Great, thanks, and we're both happy to be here. So I'm from the University of Maryland. I work in a big Earth System Science Center, so roughly about 200 atmospheric physicists and people that do that sort of work. I'm kind of the one person who's embedded within that center to try to translate what they do into useful things like informing supply chain decisions. And my co-author, Laharesh Kuntaka, is at the Rochester Institute of Technology. And so what we're going to talk about real quick at the end here is, you can think of it as an exploratory data analysis that we've been undertaking over the past few years that'll maybe provide a bit more detail about the scope of the problem that we've heard about in the previous two presentations. And so this has been a collaboration between the business school at Maryland, where Laharesh was a PhD student, my center, and a firm called Resolink, which, if you all aren't familiar with, is a fairly large supply chain risk consultancy that was founded a bit over 10 years ago. They work with companies to understand their supply chain risks in a variety of ways, but I won't go into too much detail on what they do. For the sake of time, I think Anders and Andreas did a great job of introducing the problem. So I'm just gonna skip past my slides on describing the problem and go straight into what we've done. We know climate change is real, risk is growing, et cetera, et cetera. What I will emphasize, and this has come out quite a bit as the field of climate services has grown. I'll just focus on this quote for a second. It was from the New York Times a few years ago. It said, "It's tricky to take scientific reports about rising temperatures and weather extremes and say what those trends might mean for specific companies and in specific locations." And I think that probably encapsulate much of the challenges that I'd imagine the journal is going to be grappling with this specific topic over the next few years. And so what we have done is we partnered with Resolink and their database to produce a few use cases on what we can try to, without too much effort, grasp the sense of the problem as it is now. And so I'm going to talk about the first use case. My colleague is going to talk about the second. The first one, which we started a few years ago, and I'll put in a plug, the results are going to come out in a week or two in Harvard Business Review, was to try to explore the intersection of site level revenue at risk, site preparedness, and exposure to increasing climate extremes in the US, China, and Taiwan. And so this was looking at about 10,000 sites. We used satellite-based measurements of heat and precipitation extremes and just broke this down into something simple, just looking at which sites had a statistically significant increase to exposure to a few just basic climate extreme indices. So just to give you a sense of what the database looks at and what we're going to show towards the end, we looked at things like revenue at risk, which we just broke into 3 standard categories. You can think of high as being, this is a site that if it goes down, a company knows they're going to be in trouble, basically. And looked at a variety of type of responses that are commonly used in supply chain management. So whether a site has a business continuity plan, which is essentially their plan for what they're going to do if something goes wrong, how long it takes them to bring the site back up or switch to an alternative site, and whether they had both. So what I'm showing here is that result broken down across the US and China and Taiwan. The interesting pieces here are you see, one, in the US at least, that you see a fairly large percentage of sites that have none of these sort of preparation measures put in. Across China and Taiwan, you see quite a bit more, and you start to see, if you were, I guess, assuming there was sort of rational planning involved, you would see these more at higher revenue at risk sites. You would want to protect those sites more. Then we paired this with data on increasing climate extremes. And so this is a map showing all of the sites across the US. The ones in red are ones that were experiencing increasing climate extremes. This is mostly increase in heat extremes and precipitation extremes, and about 1/3 of the sites are exposed in some way to these historical trends. In China and Taiwan, you actually see about 94% of sites are exposed to increasing climate extremes, and these are almost all heat related. And so the interesting sort of thing you can do with the merging of these sort of data is start looking at what the intersection looks like. So what these plots show, again, broken down by the US and China and Taiwan, is looking at revenue at risk, the types of responses, and then whether or not sites experienced a hazard or not. And so part of what the idea behind this was to try to start looking at, can we pick up a signal? Are supply chain sites starting to react to signals that they're starting to see increases in climate extremes? It turns out in the US, especially for high revenue at risk sites, you can see the difference in the stacked bars here. We did start to see some difference in that sites that are exposed to increasing climate hazards tend to have a higher likelihood of having some sort of response. We saw this less so in China and Taiwan. And again, just to highlight, these are higher levels of response capacity to begin with. And if you think about, the riskiest sites are one that are, one, have a high revenue at risk and have no sort of response capacity in place. What you see is that amongst the, what is it, a third of sites in the US that are exposed to increasing climate extremes, 18% of those are actually at the greatest risk because they're high revenue at risk and no plans in place, basically. So it gives you a sense of the scope of the problem as it exists now. You can imagine that as the signal for climate extremes becomes greater over time, this number is probably going to increase. In China and Taiwan, that same analysis shows that about 11% of exposed sites have a sort of greatest climate risk. And so the caveat for this sort of initial use case is that we used individual sites that had no information about how they were connected or sort of what their supply relations are. And so my colleague now is going to present a use case number 2 to show what that looks like once you start expanding that across the globe and showing relationships between sites.
Yep. Thanks, Mike, for sharing your thoughts on the climate change and the variations in the climate extreme. So here, Mike discussed that sites are susceptible to extreme climate extremes like changes in precipitation and changes in temperatures. So here I'm going to actually present the hazards that are a result of these extreme climate changes, and I look at the natural hazards or natural disruptions that will actually impact the operations of the sites. And here we are expanding the same analysis to global locations with 700,000 sites, and which includes 250,000 firms with 600,000 supply chain relationships, which spans across all the 3 types of supply chain, and in some cases even the 4th tier of supply chain. So I can go to the next slide. So these are the 730,000 global locations with core activities like manufacturing, wafer fabrication, assembly and testing, and so on. So we see that the 43% of the sites in our database have experienced at least one type of natural disaster event in the last 10 years. So we look at 4 different types of events, as Anders discussed in his first presentation. They are hurricanes, typhoons, the second being tornadoes, the third floods, and 4th forest fires. So we see that 43% of the sites in across the globe experienced at least one of these 4 types of events. So the majority of the events are related to hurricane-related disruptions, which are mainly located in the eastern coast of USA and east coast of China, which account for 34% of the disruptions. And the next is floods. So around 23 to 30% of the sites have experienced at least one flooding event in the last 7 to 10 years. And the last being the forest fires, which are more common in the western coast of USA, in the California area, and in the east coast of Australia around Sydney and Melbourne and Adelaide areas. So can you go to the next slide? So these are the locations that have some sort of preparedness, and the first kind of preparedness that we look at are having at least some sort of business continuity plan in place. So basically, a business continuity plan is designed to avoid or mitigate any risk or any disruption, and to reduce the impact of any crisis if it occurs at the site, or if the site goes down, to bring the site back to a usual business operations as quickly as possible. And we see that only 26% of the sites across globe have some sort of business continuity plan in place, and 74% of the sites are vulnerable and unprepared for disruptions in their operations. So yeah, can we go to the next slide now? Yeah, so the other type of resiliency measure that we look at are having a pre-qualified alternate backup site. If the primary site goes down, the production location can shift their operations to a secondary site where they can continue their business operations. And this alternate backup site has to be pre-qualified. That means it has to be pre-tested for the policies and procedures that will enable it to transfer the activities from the primary location to this alternate backup location. And we see that only 2% of the sites across globe have some sort of pre-qualified or alternate backup site where they can shift these business activities in case of any disruption. Can you go to the next slide? Now now comparing both the sites that had a disruption and sites which have some sort of business continuity measure, which is having a business continuity plan or having a pre-qualified alternate site. So we see that only 24% of the sites that experience some sort of disruption related to any weather event like hurricane, forest fires, tornadoes, or floods have a business continuity plan that they can use, that they can trigger to continue their operations, or they can shift to an alternate location. So we see that only 24% of the sites were prepared, and the rest 76% are unprepared to handle this kind of weather-related events. So can we go to the last one? Yeah. In the first few slides, we looked at the locations within the firm supply chain, but we are expanding this analysis to a network-wide analysis. So here is an anonymized firm with two types of suppliers. So we have the first tier suppliers and the second tier suppliers. So for example, if this firm is located, let's say in the middle of USA, where it is not being exposed to any kind of natural hazard events, but still the extended supply chain, being the first tier or second tier suppliers, they are located all across the globe, majorly in the east coast of USA or in the Europe or in India, which are susceptible to different natural hazard events. So it is very important for these firms to look beyond what they are doing in their supply chains and look beyond to their first tier and second tier suppliers to reduce any to devise any risk mitigation plans. So we can go to the next slide. So again, much work has to be done to improve supply chain resilience to climate risk, and we presented two use cases which helps us have a greater visibility and decide any options to enhance the resiliency or to shift the primary site to any secondary site if there is any disruption at the primary location.
Well, great. Thank you, Mike and Laharesh, for sharing your work here. We did have a couple of questions that came in. While we field questions, Jackie just posted the survey out to everybody. So I had mentioned there were 3 or 4 questions that we'd like for the participants to respond to in preparation for our next webinar. So hopefully you saw that link come through the chat tool. While you work on that survey, we'd like to follow up with Mike and Laharesh on some questions. One question that we had was relating to that revenue at risk measure that you were talking about in your presentation. We were hoping that you could provide a little bit more information about it. Does that include, do you measure profit, or is that strictly sales or revenue that's generated by the site?
Yeah. So I think the revenue at risk measure, we can take a small example on how that revenue at risk measure is calculated. So for example, if we take iPhone as an example, so we have the button that the home button that goes into the iPhone. So the revenue at risk measure is if the site goes down, so what amount of revenue is at risk at the OEM. So in this case, Apple, if the site that is producing these home buttons, if it goes down, so what is the overall revenue that is at risk because of the stoppage in production that can happen at the OEM.
Great, thank you. And then can you also elaborate a little bit about what you mean by alternative sites? I mean, what does that mean as it relates to the focal site or the organization that you are capturing in your data set?
So the alternate site or a backup site is where they can shift the manufacturing activities or fabrication activities when the primary site goes down. Let's say, for example, in Taiwan, so there are lots of sites, sites do wafer fabrication. So if the primary site goes down, so do they have any pre-qualified alternate site where they can shift this production to? So can they activate the backup site so that their business operations can continue without any disturbance, and so their customers or suppliers in case of the primary site goes down?
So you're saying that you're finding through your research that 75% of the sites in this global database do not have such plans or abilities?
So we find that 98% of the sites do not have any alternate backup sites, but there are 24% of the sites which have some sort of business continuity plans in place. And the business continuity plan doesn't have to be an alternate backup site. It can be having a emergency response team or crisis management team, or different kinds of teams that they can activate to faster recovery or to bring the site back to action when it goes down. But yeah, 2% of the sites only have backup sites and 98% do not have any kind of backup locations.
Great, thank you. We do have a couple of final questions for Anders and Andreas. One question that came in is about degrowth as a solution to the climate crisis. Do you think degrowth is a potential strategy here, or is that unrealistic?
I don't. Oh, sorry. No, go ahead.
No, so you go ahead, Anders.
I have a particular opinion on this, and I've published this, but unfortunately only in German, because I'm still searching for the New York Times to take it in English. Anyway, actually they keep saying they come back, but they never do. I don't think growth is actually something very deep that provides the incentive in society, and I don't think that we can give up this idea. Now, growth per se is simply a growth in value, right? So it doesn't have to be accompanied with a destruction. But in order to avoid that, we really have to make deep changes in our society, and solving the climate crisis, which means getting to zero carbon emissions, will give you one global and very fundamental aspect of the economy and a way to change it on a global scale. So my hope is that we'll solve that without losing the incentive of a growth idea, but learning at the same time how to do value growth without destruction. And there's a mathematical concept for that that is from chaos theory. It's called folding, in which you can have infinite growth in finite space, and that's what we got to do. But there's way too short time to explain this here.
Yeah, maybe just to add, of course, growth can be defined in different ways. You could say, there's the saying, those who believe that you can have infinite growth in a finite world is either an idiot or an economist. But you can also say, what is growth? Is it material growth? Do we need to dig deeper and deeper to get more material? Or is it also maybe about selling services instead of products? So there's very different ways also to create circularity instead of linearity. I think then there might not even be any conflict between growth and the finite planet. Anders.
Thank you, Andreas. And Anders, you have a comment, a follow-up comment?
It's just very briefly, yes. Perhaps, if we make our energy supply fully renewable, there's actually, we can have much more energy, right, than we currently have. Because there's much more available than in fossil fuels. So we can actually start to solve our sustainability crisis, which is the recycling crisis. And under the second law of thermodynamics, you can only cycle back to the original state if you put energy into the system. So we will eventually need much more energy in order to actually really start to work on the recycling crisis, which sounds very, very boring, but we will not be able to avoid it. The climate problem is only the first step.
Great, and we have one final question that came in the chat, and that is the idea of removing CO2 emissions from the atmosphere. What is your opinion on that?
Yeah, I mentioned this earlier. We don't have enough. We don't have the technology that is actually scalable. That we'll have to go to zero emissions anyway, and then the little that's left, burning coal. It's about burning oil, gas, and coal, right? Because this is the sea that has been out of the atmosphere for hundreds of millions of years. Burning old trees, that sea that has been carbon that has been out of the atmosphere for hundreds, potentially thousands of years. That's bad too, but we're still doing this, right? So eventually we'll use this little bit of capacity that we have in order to get CO2 out of the atmosphere to cloak the holes in the system. Yeah, right. But it's only a tiny contribution.
Great, thank you. Well, I'd like to go ahead and bring this session to a close. Again, well, thanks to all our presenters and to JSCM for hosting today's session. It was a very interesting, very exciting, and very important topic that we discussed this morning, this afternoon, this evening, depending on where you are located. We'll have another session again, and I hope that you provided your comments to the survey so that we can inform the presenters about what is on your mind and what are your thoughts. So thank you again, and we hope to see you next time.